In number 12, we're asked to explain why each of the following systems does not have a solution. So the thing we're kind of looking here is our normals and our Cartesians. If they don't have a solution, that generally means that we have some parallel planes happening here, or maybe coincident planes, or some sort of situation like that. So let's look at letter A. What do I notice about letter A? Well, right off the bat, I notice that these two planes have the same normals, but different scalars. So I have two parallel planes being cut by a third. So no solutions possible. No solutions. Our reasoning is two parallel planes, first two, and they're being cut by the third one. I know they're cut because the third one is um, different, right? It's got different normal. If we look at B, what do I notice in B? Well, in B, I just looking straight down your columns here, you notice that all three of these have the exact same normals, but all three scalar values on the right-hand side there are different. So what's that tell us? Well, these are three parallel planes. And of course, you're never going to have solutions are all parallel to each other. Okay, let's look at letter C. Looking for combinations. I notice for sure that these two are both the same. So those are at least parallel, and yeah, these are different, so parallel. And then if I look at the first one, I notice that if I times all this by 2, it comes out to 2x minus 2y plus 2z equals 18. Hey, that's this equation. So I actually have two coincident, number 1 and number 2 coincident, and planes, and one other parallel one. Well, those can't ever meet. The first two will be meeting everywhere, but they'll never meet the third one, right? And if I look at D, what do I notice in D? Well, I look at this one and I say if I times it all by 3, I get this one. Okay, so those two things are coincident. And if I times the first one by 2, at least the normal part of it, times that by 2, I end up with this. But 4 times 2 doesn't make 5, right? So the purple planes, sorry, number 1 and 2, and 1 and 2 are coincident again, and they were scalar multiples. And 1 and 3 are parallel. So can these ever be solved? No. We have infinite solutions for 1 and 3, or 1 and 2, but no solutions ever for 1 and 3.